Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to bring to you class 11th NCERT chapter number 3, that is trigonometric functions, and today we are going to deal with exercise 3.2 in this session. So let's continue with the first question. What does the first question say? Let's take a look at this. Find the values of other 5 trigonometric functions in exercises 1 to 5. Okay. The first one says that cos x equals minus 1 by 2 and x lies in third quadrant. X lies in third quadrant, cos x equal to minus half. And what are we supposed to find? We are supposed to find other 5 trigonometric functions for this angle, right? So how do we go about finding these things? First, I'll tell you a simple approach of solving this question. A simple approach of solving this question, yes. X lies in the third quadrant. So let's solve this. X lies in the third quadrant over here. And which all trigonometric functions are positive, which are negative in this quadrant. When we talk about our ASTC rule, we know that tan and cot are 2 trigonometric functions which are positive in this quadrant, and other 4 trigonometric functions would be negative in this quadrant, right? What else? Cos x is equal to minus 1 by 2, or you can say that if you had a right angle triangle where this angle is theta, cos theta would be half for that matter, right? We'll have to consider the modulus value, the positive value of that. Cos theta equals half tells us that this base length, this base is 1, this is 2. Cos theta is equal to half tells us this. Once you are aware of this much, we can easily find this perpendicular. The length of perpendicular would be hypotenuse square minus s square, which is 4 minus 1 under root, which is root 3. This will be equal to root 3. After you are aware of this much, what you will simply do is write the values. How can we write the values? We already have cos x equals to minus half. Sec x can be easily written as a reciprocal of cos x, or you can note hypotenuse upon this, but sec would be negative, so this is actually minus 2, right? From here or here directly. Sin x would be equal to what? Sin x is simply equal to root 3 upon 2, but there's a catch. Since x lies in the third quadrant, this value has to be minus root 3 by 2, that's important. Cosec x would be reciprocal of this, so minus 2 by root 3. Tan x will be simpler. Tan x, what is tan x equal to? Now tan x over here, as you may clearly observe, would be equal to root 3, but with a plus sign, because this lies in the third quadrant. Tan x is plus root 3 and cot x is 1 by root 3. This is what you get. This is 1 by root 3. Cot x would be 1 by root 3. Now this is a simple approach of dealing with this question by drawing this right angle triangle, and in general this is what you can follow. But when you talk about NCERT, these people want you to do some calculations and find using some method. Now what is the approach, what is the method that they want in general, and the method which you will be using while appearing for your exams and all in the school only. For JEE purposes, this is something which you'll remember, and this is something which you can use gradually. But when you talk about the school exam purposes, let's talk about that. So cos x equals minus half implies, or the approach which the NCERT people want you to follow is this, that cos x equals minus 1 by 2. They say that there is no need to draw any diagram, any triangle. We could draw the triangle and find the values very easily, but then they say, okay, cos x equal to minus half is something which you know. So on the basis of that, you can easily find sec x. Sec x equals 1 upon cos x, which implies that sec x would be equal to minus 2. That's the first value that you get. On the basis of cos x equals minus 1 by 2, the value that you will get for sec x is minus 2, which is very easy. Okay. Then you will talk about another important trigonometric result, identity. What is that? Something which relates cos x to some other trigonometric function. Now cos x and sin x are easily related by the identity sin square x plus cos square x equals 1. We'll use that, right? Since sin square x plus cos square x equals 1, so therefore we can easily get the value of sin square x over here. So therefore sin square x plus cos square x is minus 1 by 2, the square would be 1 by 4 equals 1, which gives me sin square x is equal to 1 minus 1 by 4, which is 3 by 4. Okay, therefore this will further imply that sin x equals, take the square root, you will get a plus or minus square root of 3 by 2. But since x lies in the third quadrant, which value? Will you take the positive value or negative value? Since x lies in the third quadrant, sine is negative in that quadrant. So since x lies in third quadrant, therefore sine x would be equal to minus root 3 by 2. That's the first, second and third trigonometric function which you have found. Now with the help of this sine x, you can find next cosec x very easily. Cosec x, which will be equal to 1 over sine x, which is simply equal to, which implies that cosec x is equal to reciprocal of this, which is minus 2 by root 3. Now that's the next trigonometric ratio that you obtain very easily. What else? You can also find other two trigonometric ratios which remain, that are, those are tan x. Tan x equals, since tan x is equal to, in terms of sine and cos, you know that tan x is equal to sin x upon cos x. So this is sin x. Sin x is minus root 3 upon 2 whole divided by cos x, which is minus 1 by 2. This gives me tan x is equal to, minus minus will get cancelled, denominators 2 will get cancelled, and what you will get is this. Tan x is simply root 3. If x is lying in the third quadrant, tan x was supposed to be positive. Yes, that's what you're getting. And cot x, which is the reciprocal of tan x, implies cot x would be equal to 1 over root 3. This is what you get. Cot x will be equal to 1 over root 3. Those are the 6 trigonometric ratios. One was already given, second, third, fourth, fifth, sixth, and that's what you get finally. Right? Is that all? Yes, that's the complete solution of this question. Let's take a look at this question. Finding values of all other 5 trigonometric ratios, trigonometric functions, given that sin x equals 3 by 5, where x is lying in the second quadrant. Now how do we approach this question? A simpler approach would be to draw a triangle very easily. Sin x equals 3 by 5. Let's say sin theta equals 3 by 5. The triangle that you will get is this triangle, 3 by 5, and this base would be actually 4, and since theta lies in this quadrant, all sine, tan, cos. So sine and cosec would be positive, other 4 would be negative. Okay, so sine x is something which we already know. Sine x is 3 by 5. Cosec x would be 5 by 3. Cos x can be found as 4 by 5, but since it is lying in the second quadrant, x is lying in the second quadrant, this will be minus 4 by 5. Similarly, tan x would be 3 by 4, but with a minus. Reciprocal sec x and cot x can easily be found. This is the simpler, shorter approach. But then drawing all of these diagrams is not something which the NCERT people love. They want you to solve using a longer approach. Let's see what the longer approach says. Longer approach says that sin x, okay, this is equal to 3 by 5, which gives me cosec x. Cosec x is the reciprocal of sin x. Yes. Let's find that cosec x first. That is equal to 5 by 3. That's the first thing that you get. Okay. Relate sin x to some other trigonometric ratio. What is the other trigonometric ratio and a sin x identity between another trigonometric ratio and sin x? Well, we have a simple identity, that is sin square x plus cos square x, which is equal to 1. Okay, this gives me cos square x is equal to 1 minus sin square x, which is 1 minus sin square x. Sin square x is 3, sin x is 3 by 5, sin square x would be 9 upon 25. This will be 16 over 25. Now this is the value of cos square x. So what will cos x be equal to? Cos x will be equal to plus or minus 4 by 5. Which value should we consider? Should we consider plus 4 by 5? Should we consider minus 4 by 5? The answer lies in this. In the second quadrant, cos x is negative. So this gives me cos x equals minus 4 by 5 since x lies in second quadrant. Since x lies in the second quadrant, right? Once you have found cos x, you can easily find sec x. Sec x is the reciprocal of cos x, which will be minus 5 by 4. This is sec x. What about tan x and cot x? Tan x and cot x can now be found by taking reciprocal of sine and cos, right? Tan x is equal to sin x over cos x. Since tan x equal to this, therefore tan x is equal to, sin x is 3 upon 5, cos x is minus 4 upon 5. Taking the reciprocal, what you have is 5 will get cancelled. This is minus 3 by 4. and cot x will be equal to what? Cot x is reciprocal of this, which is minus 4 by 3. Right? This is what you get. That's a complete answer. Yes, that's a complete solution for this question over here. Let us talk about the next one. This question says that cot x is 3 by 4 and x lies in the third quadrant. We have to find the other 5 trigonometric ratios. How do you go about doing this? When it is given that cot x equals 3 by 4, one of the simpler approaches which says, let's draw a right angle triangle. Okay, if this is theta, cot theta is 3 by 4, this will be 3, this will be 4, and this hypotenuse can be easily found by the Pythagoras theorem. This will be 5, right? So cot theta is 3 by 4 and x lies in the third quadrant. In the third quadrant, this is the third quadrant, all sine, tan, cos. So tan and cot would be positive, other 4 would be negative. We can easily write sine x. Sine of x would be negative, and you can write sine theta from there, minus 4 by 5. This is what you get. Cos x would be again negative, which is minus 3 by 5. Tan x would be reciprocal of that, tan x would be 4 by 3. The other 2 can also be found, cosec x and sec x can be easily found using this approach. This is a simpler idea, but then the NCERT people want you to solve without using any diagram and all, without using any triangle and all, without using the simple concepts. So let's continue using that approach. It is given that cot x equals 3 by 4. So the first thing that you can find is tan x, which is equal to 4 by 3. This is simply the reciprocal of cot x, right? That is very simple to find. Now what next? Okay, with the help of cot x, do you have any identity which relates cot x to another trigonometric function? So we remember one trigonometric identity. What is that? That identity says that 1 plus cot square x is equal to cosec square x. Okay, since cosec square x is equal to 1 plus cot square x implies cosec square x can easily be found. 1 plus cot square x. Cot square x would be square of this. This is 9 by 16. What is that? This is 25 by 16. Okay, once you are through with this, we can easily say that cosec x will be plus minus 5 upon 4. The question is whether it will be plus 5 by 4 or minus 5 by 4, and the answer lies in the location of x. X lies in the third quadrant. In the third quadrant, tan and cot are positive, but cosec would be negative. So since x lies in third quadrant, we can say that cosec x will be minus 5 by 4. Okay, since cosec x is minus 5 by 4, we can easily get the value of sin x. Sin x is reciprocal of this, which is minus 4 by 5. Okay, what else? Can we find cos x and sec x as well? Yes, cos x can be found with the help of values of tan x and sin x. How do we find that? Cos x, since tan x equals sin x upon cos x would be equal to sin x over tan x. Since this equals this, which implies cos x will be equal to sin x, which is minus 4 upon 5, whole divided by tan x, which is 4 upon 3. This gives me cos x equals what? Cos x will be equal to, can you observe that the 4's in the numerator will get cancelled. This 3 will reach the top and there will be a 5 in the denominator. This is minus 3 by 5. Cos x is minus 3 by 5. And after cos x, you can easily get sec x. The reciprocal of cos x is sec x, which is minus 5 by 3. Those are the values. You can verify that the values which we obtained directly are exactly same. This is not something which was asked, right? This is something which we can remember to check. Right, that's a complete solution of this question over here. Let me get aside so that you can take a look. Let's talk about this question. Sec x equals 13 by 5 and x lies in the fourth quadrant. We have to find the other 5 trigonometric functions. Sec x is 13 by 5. Okay, so it is given that sec x equals 13 by 5. Okay, cos x would be reciprocal of this. This is 5 by 13, which is very simple. Okay, and since you have practiced using that idea of triangle also, what you can do is you can maybe solve this question orally as well. Now Let me give you an idea about how to solve this question orally. Cos x would be this. This is 5 by 13. This will be 12. Pythagorean triplets, right? 12 square, which is 144, plus 5 square, which is 25. 144 plus this would be 169, which is 13 square. Right. And if this angle is theta, sec x, cos x are known. X lies in the fourth quadrant, this quadrant. All other trigonometric ratios, all four trigonometric ratios, other four trigonometric ratios would be negative. Sin x will be minus 12 by 13. Tan x will be minus 12 by 5. That's what you can observe using your ideas, other ideas which you have seen, right? Using triangle ideas and all. So this is shortcut. But then the person wants you to solve using analytical approach. Let's solve. If the person wants us to solve using analytical approach, let's solve it. What do we use? We use this cos x to get another trigonometric function using some trigonometric identity. And a simple trigonometric identity is sin square x plus cos square x equals 1, which gives me sin square x is equal to 1 minus cos square x, which is 25 over 169, which is 169 upon 25 is 144 over 169. This is what you get. Implies that sin x will be equal to plus or minus 12 over 13. Now which value will you consider? Will you consider plus 12 by 13 or minus 12 by 13? That depends on which quadrant does x lie in. Since x lies in fourth quadrant, implies sin x is minus 12 by 13. Okay. And cosec x is the reciprocal of sin x. Reciprocal of sin x would be minus 13 by 12. This is what you get. Right. Once you have sin x and cos x, cosec x, you already had cos x, therefore tan x will be equal to sin x upon cos x, which is minus 12 upon 13 divided by 5 by 13. This gives me tan x equals minus 12 by 5. Oh, we found minus 12 by 5 before also, right? But that was another method, right? This is this method, solving analytically. Tan x is minus 12 by 5. What next? Implies cot x. Cot x, which will be reciprocal of tan x, is minus 5 by 12. Those are the other 5 trigonometric ratios, as you can clearly observe over here, right? Let me get aside for a bit so that you can take a look at the complete solution over here. That's all in this question. Let us solve this one next. Tan x equals minus 5 by 12. X lies in the second quadrant. Okay. How do we approach this question? A simple approach would be to draw the diagram and solve, get the values orally, for that matter. Orally, yeah. Tan theta, this triangle. If this angle is 90 degree, this is the angle. Tan implies this is 5 by 12. This will be 13, obviously, right? And x lies in which quadrant? Second quadrant. So the value of sine would be positive. Sin x would be positive 5 by 13. Cos would be negative minus 12 by 13. And tan is already negative, which is minus 5 by 12. You have used that, right? And other 3 would be reciprocals of these, right? This is something which you can do very fast. Okay. But then, in case you want analytical solution, the longer approach, how do we solve using the longer approach? Let's take a look at that also. So tan x equals minus 5 by 12 implies cot x would be reciprocal of this, which is minus 12 by 5. Okay. You know tan x and you know cot x. So what you can do is you can find another trigonometric, use trigonometric identity to find another trigonometric ratio. Tan x can be related with sec square x. This is 1 plus tan square x. Since this is 1 plus tan square x, therefore this is 1 plus tan square x would be 25 over 144, which implies 169 over 144. Okay, this is 169 upon 144, which gives me sec x is equal to plus minus 13 by 12. Which value will you consider? Will you consider the plus sign or the minus sign? That depends upon the quadrant. In the second quadrant, sec x will be negative. So since x lies in second quadrant, implies sec x will be minus 13 by 12. Okay, now we have found sec x, implies cos x can be easily found. Cos x is the reciprocal of sec x. That will be minus 12 by 13. Okay, what next? Cos x is minus 12 by 13. Therefore, sin x can be easily found, right? Tan x is sin x upon cos x. Tan x is sin x upon cos x. So, sin x would be tan x times cos x. Okay, what will this imply? This implies that sin x equals tan x. Tan x is minus 5 by 12 times cos x. Cos x is minus 12 by 13. This gives me the value of sin x very easily. Minus minus will become a plus, 12 gets cancelled. This is 5 by 13. But we found that. Yeah, we found that. Okay, but using this approach, this is the value of sin x, and cosec x, which is the reciprocal of sin x, can be easily found. This is 13 upon 5. These are 1, 2, 3, 4, 5. These are the other 5 trigonometric ratios on the basis of tan x equals minus 5 by 12. Is that all? Yes, that is all in this question over here. Let us talk about this question. Find the values of the trigonometric functions in exercises 6 to 10. We are supposed to find the value of this trigonometric function. There is sine 765 degree. How do we go about finding these values? We know a few standard values, right? We know between 0 to 360 degree, we know a few values, right? Few standard values for that matter. This 765 degree is an angle way beyond 360 degree, okay? But we know that multiples of 360 degree can be added or subtracted from the angles without altering the value of this trigonometric ratio. So sine 765 degree can be written as, you may observe, 360 degree times 1 is 360, 360 degree times 2 is 720 degrees, 720 degree is close to this, okay? So can we subtract 720 degree? Yes, this will be equal to sine 765 degree minus 360 degree times 2. Right? This is what you can write it as. We can add or subtract multiples of 360 degree without changing the value, right? This is what you will do. This is 765 degree minus 720 degree. What does that give me? This is equal to sine 45 degree. And we are very well aware of the value of sine 45 degree, which is 1 over root 2. That's the required answer for us, right? This is the required answer for this question over here, sine 765 degree. Let us talk about this one next. What does the question say? Cosec of minus 1410 degree. What can we do in this question? We can observe that adding or subtracting multiples of 360 degree will not impact the value of trigonometric ratio. Now, cosec minus 1410 degree. The first feeling that I get is add something to this. Now adding a multiple of 360 degree once will not impact much. Let's multiply 360 degree by 2 and we get 720 degree. 720 degree is still far away from this, but 720 degree times 2, it's 1440 degree. Now 1440 degree is very close to this, okay? So cosec minus 1410 degree can be written as cosec 4 times 360 degree. I'm adding this to the value minus 1410 degree. This is what I'm doing, right? So what is this? This is cosec. I'm adding 4 times 360 degree. Any multiple of 360 degree can be added or subtracted without altering. Basically, the value of trigonometric function remains same in that case, right? This is 4 times 36 would be 1440 degree minus 1410 degree. What is this? This is equal to cosec 30 degree. Okay, and cosec 30 degree is very easy. Cosec 30 degree is the reciprocal of sine 30, or if you remember cosec 30 directly, you can write it as 2. Sine 30 is 1 by 2. The reciprocal would be 2. This is what you get. This is the value. This is the final answer for this question over here. Let us talk about this one next. What is the value tan of 19 pi by 3? Now what is the value of tan 19 pi by 3? Let's try to solve this one. In terms of radians, what we can do is we can add or subtract multiples of 2 pi. 2 pi is equivalent to 360 degree, one complete rotation, right? The values repeat after 2 pi. So what you can do is we can add or subtract multiples of 2 pi. Now 19 pi by 3 is actually 6 pi plus pi by 3. Can you please observe that? This is 19 by 3 is 6 point something, right? So what you can do is we can subtract multiples of 2 pi, that is 3 times 2 pi over here. Tan of 19 pi by 3 can be written as tan of 19 pi by 3 minus 3 times 2 pi. Easily, right? We can add or subtract multiples of 2 pi. That's what you can do. So we are doing exactly that. This will be equal to further tan of 19 minus 18 pi, which is pi by 3. And tan pi by 3 is very simple. Tan pi by 3, or if you may recall, pi by 3 is 60 degree. Tan 60 degree, the value is something which we already know. This is square root of 3, and that is my required answer for this question over here. This is my required answer for this question over here. That's part 8 for us. Let us solve this one. Sine of minus 11 pi by 3. How do we go about solving this? So for solving this, we should remember one thing, that we can add or subtract multiples of 2 pi without changing the value of trigonometric function. Sine of minus 11 pi by 3. Now this minus 11 pi by 3, it is close to, you can observe, 11 by 3 is actually close to 4, right? So maybe we can multiply, we can add or subtract 4 pi, something of the sort. So we are writing this as sine of minus 11 pi by 3, which is okay, plus 2 times 2 pi. Twice that 2 times multiple of basically 2 pi. That's what we are using over here. We are adding. The value will remain same. This is sine of minus 11 pi by 3 plus 4 pi. What will this become? This is 12 pi minus 11 pi. On taking the LCM, this will become 12 minus 11, which is pi by 3 on taking the LCM. This is sine pi by 3. And the value of sine pi by 3 is very easy. Pi by 3 is also 60 degree, right? Sine 60 degree, which is root 3 by 2. This is the answer that we have, right? Sine pi by 3 is something which you should remember, that it is root 3 by 2, which is something which you already know. Now once you are through with this, that is all in this question over here. Let's talk about this question. What does the question say? Cot of minus 15 pi by 4. How do we go about solving this? Now 15 by 4 is very close to 4, right? So this is a minus, right? Cot of minus 15 pi by 4. What we can do is we can add multiples of 2 pi, or we can subtract multiples of 2 pi. Here it would be beneficial to add multiples of 2 pi. How do we do that? Within the angles, the value of trigonometric ratio will not change. This is cot of minus 15 pi by 4, and we can add 4 pi, which is actually 2 times 2 pi, right? Multiples of 2 pi can be added very easily, right? So this becomes cot of minus 15 pi by 4 plus 4 pi. Can you observe? Can you simplify this as 16 pi minus 15 pi, the numerator, on taking the LCM? This becomes cot of pi by 4. 16 pi minus 15 pi, which is pi divided by 4. And cot pi by 4, cot 45 degree, is very simple. This is 1. This is the value that we remember, and on the basis of this, yes, cot 15 minus 15 pi by 4 is equal to 1. That's the answer for this question. That's a complete solution. That's how you find this value. And with this, we come to the conclusion of this exercise, exercise 3.2 of trigonometric functions, wherein we have learned interconversion between two trigonometric ratios, and we've also learned how to find trigonometric ratios, the values of trigonometric functions for some allied angles. That's what we have learned over here. We've seen some ideas, some tricks based on that. This is all for this video over here. Till the next session, all the best.